is now, what is it, 22, 23 years in existence. We've been building cars for the last 15, 16 years to customers.
For years, electric vehicles, EVs, have dominated the conversation about the future of the automotive industry,
Koenigsegg.
with many believing that internal combustion engines, ICs, are destined for extinction. But Koenigsegg's latest innovation is proving otherwise. CEO Christian von Koenigsegg has boldly stated that their new engine will obliterate EVs, offering a groundbreaking alternative that combines extreme performance, efficiency, and sustainability, without the drawbacks of battery-powered vehicles. At the core of this revolution is Koenigsegg's free valve technology, a game-changing system that eliminates the need for camshafts, allowing for precise, real-time control of intake and exhaust valves. This results in higher power output, improved fuel efficiency, and drastically reduced emissions, all while maintaining the thrill of a high-performance combustion engine. Unlike traditional ICs, which are locked into specific fuel types and inefficient combustion cycles, Koenigsegg's engine is multi-fuel capable, running on ethanol, methanol, biofuels, and even carbon-neutral synthetic fuels. This means it can achieve cleaner performance than many so-called zero-emission EVs, which still rely on fossil fuel-powered grids and resource-intensive battery production. But just how powerful and efficient is this new engine? Can it truly outmatch the latest EVs in both performance and sustainability? And will it redefine the future of the hypercar industry? Let's take a deep dive into Koenigsegg's revolutionary engine technology and explore how it might change the game forever. Koenigsegg's revolutionary engine technology. With a revolutionary new engine, Swedish hypercar manufacturer Koenigsegg is upending the automotive industry once more. According to CEO Christian von Koenigsegg, the engine will challenge the dominance of electric vehicles, EVs. Koenigsegg is dedicated to demonstrating that internal combustion engines, ICs, can still compete with, if not surpass, electric vehicles, EVs, through radical innovation and efficiency improvements as the world's electrification trend picks up speed. Koenigsegg is pushing the boundaries of ICE technology by creating an engine that offers exceptional performance, sustainability, and efficiency without exclusively depending on batteries, in contrast to traditional automakers who are phased out combustion engines. The possible incorporation of free valve technology, a camless system that optimizes valve timing for increased power output, lower emissions, and better fuel efficiency, is one of the most anticipated features of this new engine. Because free valve engines don't use a traditional camshaft, each valve functions independently and can be precisely adjusted to meet demand. Compared to conventional combustion setups, this enables a lighter, more powerful, and more efficient engine with lower energy losses. Koenigsegg has successfully tested this technology in earlier models, and a next-generation engine that fully incorporates it could revolutionize the industry. Like the Regera, Koenigsegg is anticipated to improve efficiency through advanced hybridization in addition to free valve. By substituting a conventional gearbox for a traditional multi-gear transmission, Koenigsegg's direct drive system improves power delivery while lowering weight and mechanical losses. By combining the best features of electric torque and ICE-driven top-end performance, this configuration enables smooth power transfer. By integrating next-generation hybrid technology, the upcoming engine may go one step further and be able to function effectively in a variety of driving scenarios. Weight and energy density are two of EVs' main problems. Despite their power, batteries are very heavy and need large packs to function well. Vehicle handling, agility, and efficiency are all impacted by this substantial weight increase. The goal of Koenigsegg's strategy is to minimize weight while producing power levels that are on par with or higher than those of electric hypercars. A compact hybrid system coupled with a lightweight, highly efficient internal combustion engine could deliver immediate acceleration while preserving excellent driving dynamics. This could improve the handling, range, and practicality of Koenigsegg's new hypercars compared to EVs. The sustainability aspect of Koenigsegg's new engine technology is yet another significant benefit. Although EVs are frequently viewed as the clean energy of the future, the production of batteries actually depends on rare earth minerals like nickel, cobalt, and lithium. The long-term viability of widespread EV adoption is called into question by the substantial ethical and environmental effects of mining these materials. Koenigsegg's engine might be built to run on biofuels or synthetic fuels, which could provide a carbon footprint that is almost zero without the need for additional infrastructure. Synthetic fuels are a feasible substitute for widespread electrification because, in contrast to conventional gasoline, they can be made with renewable energy sources. The driving experience, which is still a crucial component of high-performance cars, has also been underlined by Christian von Koenigsegg. The emotion, sound, and mechanical connection that make driving genuinely thrilling are all missing from EVs, according to many enthusiasts. Even though EVs are incredibly fast, the dynamic nature of a well-tuned combustion engine can seem more captivating than their quiet operation and consistent torque delivery. Performance enthusiasts will still have an alternative to electric powertrains, thanks to Koenigsegg's new engine, which is expected to combine contemporary innovations with the excitement of conventional combustion power. Raw straight-line speed isn't everything, even though EVs like the Tesla Model S Plaid and Rimac Nevera have dominated acceleration benchmarks. In areas where battery-powered vehicles suffer from range and charging constraints, a well-designed ICE hybrid system may provide more balanced performance, thriving in top speed, endurance, and long-distance driving. Koenigsegg's strategy might work better for high-performance cars because it has quicker refueling times, a higher energy density, and less dependence on charging networks. Although it may sound audacious, Koenigsegg's assertion that this engine will obliterate EVs shows their unwavering faith in their ability to innovate. Koenigsegg is demonstrating that internal combustion technology still has space to advance, in contrast to mainstream automakers that are completely switching to electric vehicles. The goal of their next engine is to reinvent ICEs in order to meet contemporary efficiency standards, lower emissions, and achieve performance levels that are higher than those of EVs. Ultimately, by providing a strong substitute for complete electrification, this new powertrain has the potential to completely transform the hypercar market. Koenigsegg is once again at the forefront of transforming automotive engineering, regardless of whether it will completely replace EVs or coexist with them as a high-performance alternative. Their creative strategy guarantees that the legacy of internal combustion engines will live on, which may be the most exciting development in the world of high-performance automobiles to date. How free valve technology works in Koenigsegg's new engine. Koenigsegg's free valve technology is a groundbreaking innovation that eliminates the traditional camshaft, replacing it with a fully variable valve system controlled by pneumatic, hydraulic, and electronic actuators. This cutting-edge system allows for precise, real-time adjustments to valve timing, optimizing airflow, fuel injection, and combustion efficiency in ways that conventional camshaft-driven engines cannot achieve. By enabling independent control of intake and exhaust valves, free valve technology significantly enhances power output, fuel economy, and emissions control while reducing engine weight and mechanical complexity. Unlike traditional engines, where valves open and close in fixed sequences dictated by camshaft lobes, free valve allows each valve to operate independently based on real-time driving conditions, ensuring optimal performance across different engine loads and speeds. First introduced in Koenigsegg's tiny friendly giant TFG engine, a 3-cylinder twin-turbo hybrid powertrain used in the Gemera. This technology is now being further refined in Koenigsegg's latest engine, promising even greater efficiency and performance. One of the key advantages of free valve technology is its ability to seamlessly switch between different combustion cycles, such as Otto, Miller, and Atkinson, depending on the required balance of power and efficiency at any given moment. This adaptability results in significant fuel savings and lower emissions without sacrificing performance. Additionally, by eliminating the camshaft and associated components like timing belts and rocker arms, free valve technology reduces the engine's overall weight, improving the vehicle's handling and agility while enhancing its power-to-weight ratio. Another major benefit is its compatibility with multiple fuel types, including gasoline, ethanol, methanol, and synthetic fuels, making it a flexible and future-proof alternative to traditional combustion engines and electric powertrains. By optimizing combustion efficiency, free valve technology also reduces harmful emissions. allowing engines to meet stringent environmental regulations while maintaining high performance. Furthermore, Koenigsegg has successfully integrated free valve with hybrid electric systems, as seen in the Gemira, where it works in tandem with electric motors to deliver instant torque, rapid acceleration, and improved overall efficiency. This hybrid integration leverages Koenigsegg's direct drive system, which eliminates the need for a conventional multi-gear transmission, further reducing mechanical losses and improving power delivery. Compared to electric vehicles, EVs, which rely on heavy battery packs and require extensive charging infrastructure, Koenigsegg's free valve-powered engine offers several advantages, including lower weight, faster refueling, and reduced dependence on lithium and other rare earth minerals used in battery production. While EVs provide instant torque and zero emissions at the tailpipe, their overall environmental impact is offset by the mining and manufacturing processes involved in battery production, as well as energy losses in charging and electricity generation. In contrast, Koenigsegg's free valve engine, especially when running on carbon-neutral synthetic fuels, offers a more sustainable approach to high-performance automotive engineering. By delivering the responsiveness and efficiency of an electric powertrain while maintaining the visceral experience of an internal combustion engine, free valve technology represents a significant leap forward in ICE development. Additionally, the absence of a camshaft allows for greater packaging flexibility in engine design, enabling automakers to create more compact and aerodynamically efficient vehicle layouts. The reduced mechanical complexity also results in lower friction losses, improving overall durability and reliability. Another major advantage of free valve technology is its ability to deliver instant boost without turbo lag, as precise valve timing adjustments allow for optimal turbocharger spool-up and airflow management. This leads to improved throttle response, making the engine feel more naturally aspirated despite being turbocharged. Koenigsegg's continued refinement of this technology is expected to push the boundaries of ICE efficiency and performance even further, challenging the widespread narrative that internal combustion engines are obsolete in the face of electrification. With its ability to achieve near-zero emissions, superior power output, and unmatched flexibility in fuel usage, free valve technology could redefine the future of high-performance automotive engineering. By leveraging this system in its upcoming models, Koenigsegg aims to demonstrate that internal combustion engines still have a place in a world increasingly dominated by EVs. What makes Koenigsegg's new engine more efficient than traditional engines? Koenigsegg's new engine achieves superior efficiency over traditional internal combustion engines through its revolutionary free valve technology, which eliminates the conventional camshaft and allows fully independent control of each intake and exhaust valve using pneumatic, hydraulic, and electronic actuators. This innovation optimizes air intake, fuel combustion, and exhaust flow in real time, significantly enhancing power output while reducing fuel consumption and emissions. Unlike traditional engines which rely on fixed valve timing dictated by a camshaft, free valve technology enables dynamic, on-the-fly adjustments to valve operation, allowing the engine to seamlessly switch between different combustion cycles, such as Otto, Miller, and Atkinson cycles, depending on the driving conditions, ensuring the perfect balance between power and efficiency at all times. This flexibility means the engine can maximize fuel efficiency during cruising, while delivering high performance under acceleration, something that conventional engines struggle to achieve due to their fixed valve timing limitations. Additionally, the absence of a camshaft and related mechanical components, such as timing belts, cam gears, and rocker arms, significantly reduces parasitic losses, meaning more of the engine's power is directly transferred to the wheels instead of being lost to mechanical resistance. The result is greater fuel economy, lower emissions, and enhanced throttle response compared to conventional ICE designs. Furthermore, Koenigsegg's new engine is designed to be multi-fuel compatible, capable of running on gasoline, ethanol, methanol, and synthetic fuels, making it a future-proof alternative to traditional combustion engines and even electric powertrains, which are heavily dependent on battery technology and charging infrastructure. By optimizing combustion efficiency and reducing waste, this engine produces fewer carbon emissions, especially when running on carbon-neutral synthetic fuels, positioning it as a viable solution for high-performance applications in a world that is shifting toward cleaner energy sources. The integration of hybrid electric systems further enhances its efficiency, with electric motor assistance for instant torque, regenerative braking to recover lost energy, and Koenigsegg's direct drive system, which eliminates the need for a conventional multi-gear transmission, thereby reducing energy losses associated with traditional gear shifts. Another major advantage is the engine's lightweight design, which improves the vehicle's power-to-weight ratio, handling, and overall efficiency, as opposed to heavy battery electric powertrains, which require large battery packs that add significant mass. Free valve technology also allows for precise turbocharger control, reducing turbo lag and ensuring optimal boost levels at all times, further improving the engine's responsiveness and power delivery without sacrificing efficiency. Compared to traditional engines that operate within narrow efficiency bands, Koenigsegg's free valve system ensures the engine maintains peak efficiency across a wider range of speeds and loads, making it a highly adaptable powertrain suitable for various driving conditions. In contrast to electric vehicles, EVs, which suffer from energy losses during charging and reliance on environmentally intensive battery production, Koenigsegg's new engine offers a cleaner and more practical solution, especially when synthetic fuels are factored into the equation. By reducing friction, improving combustion precision, eliminating unnecessary mechanical components, integrating hybrid technology, and enhancing fuel flexibility, Koenigsegg has engineered an internal combustion engine that is not only more efficient than traditional counterparts, but also capable of competing with and even surpassing electric alternatives in certain aspects, proving that ICE technology still has untapped potential in the era of automotive electrification. What types of fuels can the new engine run on? Koenigsegg's new engine is designed to run on a variety of fuels, making it one of the most versatile and future-proof internal combustion engines ever developed. Unlike traditional engines that are optimized primarily for gasoline, this advanced powertrain can seamlessly operate on gasoline, ethanol E85, methanol, synthetic fuels, biofuels, and even hydrogen-based fuels, thanks to its free valve technology, which allows fully independent control of intake and exhaust valves. This revolutionary camshaft-free system enables the engine to adapt in real time to different fuel types by adjusting valve timing, lift, and duration, optimizing combustion efficiency for each specific fuel blend. Gasoline remains a primary fuel option, providing the high energy density needed for performance applications, but the engine's ability to switch between fuels makes it far more adaptable than conventional ICE designs. Ethanol, E85, is another key fuel it can utilize, offering higher octane ratings, increased knock resistance, and cleaner combustion, leading to lower carbon emissions while maintaining high power output. Additionally, methanol, a fuel that burns cleaner than gasoline and can be produced from renewable sources, is fully compatible with this engine, allowing for greater sustainability without sacrificing performance. One of the most exciting aspects of Koenigsegg's fuel strategy is its emphasis on synthetic fuels, which are artificially created using captured carbon dioxide and renewable energy sources. These fuels provide the performance characteristics of gasoline while being nearly carbon neutral, meaning the engine can deliver high power output with minimal environmental impact. By incorporating synthetic fuels, Koenigsegg effectively reduces dependency on fossil fuels while keeping the thrill of an internal combustion engine alive in an era dominated by electrification. Furthermore, the engine is also capable of running on advanced biofuels, which are derived from organic materials and offer significant reductions in greenhouse gas emissions compared to traditional gasoline. Unlike EVs, which rely on battery packs requiring resource-intensive mining for lithium, cobalt, and nickel, a multi-fuel internal combustion engine like Koenigsegg's presents a more sustainable solution by leveraging readily available renewable fuels. Another advantage of free valve technology is its ability to modify combustion parameters dynamically, ensuring that no matter the fuel type, the engine can achieve optimal ignition timing, air-fuel mixture ratios, and compression levels for maximum efficiency and power. Additionally, Because synthetic and biofuels can be used in existing infrastructure with minimal modifications, this engine provides a practical transition solution for reducing emissions without requiring an entirely new energy grid, as is the case with EVs. The ability to burn multiple fuel types also means that Koenigsegg's new engine is less vulnerable to fuel shortages or fluctuations in energy supply, ensuring consistent performance regardless of market conditions. Hydrogen-based fuels are another potential alternative, as free-valve technology allows the engine to handle different combustion dynamics, making it capable of running on hydrogen-enriched fuel blends. This makes it an attractive option for future applications where zero-carbon combustion may become a regulatory requirement. Unlike traditional hydrogen fuel cells that require complex infrastructure and have energy conversion losses, Koenigsegg's engine could theoretically run on liquid hydrogen or hydrogen-derived synthetic fuels, delivering instant refueling capabilities, high power output, and extended driving ranges similar to gasoline-powered vehicles. This gives it a significant advantage over fully electric powertrains, which rely on long charging times and limited charging networks. The engine's adaptability extends beyond fuel compatibility, as Koenigsegg's hybrid integration allows it to work in combination with electric powertrains, ensuring that even when alternative fuels are in limited supply, the vehicle can maintain performance using stored electric energy. This hybrid synergy is particularly beneficial in reducing overall fuel consumption while maintaining instant torque delivery and high-speed efficiency. In contrast to traditional combustion engines, which require significant hardware modifications to switch between fuels, Koenigsegg's new engine self-adjusts via software-controlled free-valve actuators, making it highly adaptable and efficient across all fuel types without the need for mechanical reconfiguration. This makes it a long-term, sustainable alternative to both conventional gasoline engines and battery electric vehicles, BEVs, providing flexibility in energy sources without compromising driving dynamics. By eliminating the restrictions imposed by traditional camshafts, Koenigsegg's free-valve engine is able to extract maximum energy from each type of fuel, resulting in higher efficiency, lower emissions, and optimized performance. The combination of multi-fuel capability, advanced combustion control, and hybrid electric integration makes this engine one of the most innovative powertrains in modern automotive engineering, proving that internal combustion technology still has a viable and environmentally responsible future in a rapidly electrifying world. How does the new engine's emissions level compare to electric vehicles? Koenigsegg's new engine, equipped with free-valve technology, offers a compelling alternative to electric vehicles, EVs, by significantly reducing emissions while maintaining the performance and refueling advantages of internal combustion engines. Unlike traditional gasoline engines, which suffer from inefficient combustion and high carbon dioxide, CO2 output, Koenigsegg's advanced engine is designed to operate on multiple fuel types, including synthetic fuels, biofuels, ethanol E85, and methanol, all of which produce significantly lower emissions compared to fossil-based gasoline. The free-valve system optimizes air intake and combustion by allowing independent control of each intake and exhaust valve, leading to a more complete and efficient burn of fuel, thereby reducing unburned hydrocarbons, carbon monoxide, CO, and nitrogen oxides, NOx. When running on carbon-neutral synthetic fuels, which are produced by capturing CO2 from the atmosphere and converting it into liquid fuel using renewable energy, the engine's net emissions approach zero, making it comparable to the life cycle emissions of EVs, which depend on electricity generation sources for charging. While electric vehicles produce zero tailpipe emissions, their overall carbon footprint is largely determined by how the electricity used to charge them is generated. In many parts of the world, electricity grids still rely on coal, natural gas, and other fossil fuels, meaning that EVs indirectly contribute to CO2 emissions. Additionally, the production of lithium-ion batteries, which power EVs, involves intensive mining of rare earth metals such as lithium, cobalt, and nickel, processes that generate significant CO2 emissions, habitat destruction, and water pollution. Studies have shown that the manufacturing emissions of an EV battery can be equivalent to driving a gasoline car for several years. meaning that an EV must be driven for tens of thousands of miles before its carbon footprint becomes lower than that of an efficient internal combustion engine running on sustainable fuels. Effectively negates this advantage by emitting significantly lower CO2 over its lifetime compared to conventional gasoline engines, while avoiding the environmental downsides of large-scale battery production and disposal. Another major advantage of Koenigsegg's engine is its higher thermal efficiency due to precise valve timing and optimized fuel-air mixture control, reducing wasted energy and emissions. Unlike traditional engines that lose energy through incomplete combustion, Koenigsegg's free-valve engine adjusts combustion cycles dynamically, ensuring maximum fuel utilization and minimal pollutant output. Furthermore, Koenigsegg has integrated hybrid technology, allowing the engine to work alongside electric motors, which provide instant torque and regenerative braking, further reducing fuel consumption and emissions. This hybrid setup enables the vehicle to operate in zero-emission electric mode at low speeds, similar to a plug-in hybrid EV, while relying on its highly efficient free-valve engine for high-speed and long-distance driving, reducing reliance on charging infrastructure. One of the main criticisms of traditional internal combustion engines is their particulate matter PM emissions, which contribute to air pollution. However, Koenigsegg's engine, when running on biofuels or synthetic fuels, produces lower PM emissions than gasoline and diesel engines, making it cleaner in urban environments. Additionally, because it doesn't require excessive fuel enrichment, a common issue in turbocharged gasoline engines that leads to high PM and CO2 emissions, it operates at leaner air-fuel ratios, leading to cleaner combustion and reduced toxic byproducts. In contrast, electric vehicles generate emissions through brake pad wear and tire degradation, which release microplastics and metal particulates into the air. Since EVs tend to be heavier due to their large battery packs, they often produce more non-tailpipe emissions from tire and road wear compared to lightweight, high-efficiency combustion vehicles like those using Koenigsegg's free-valve engine. Another critical factor in emissions comparison is end-of-life disposal. EV batteries degrade over time and must be recycled or replaced, creating a significant environmental burden. Battery recycling infrastructure is still developing, and improper disposal can lead to toxic chemical leakage and long-term ecological damage. In contrast, Koenigsegg's engine, when running on renewable liquid fuels, can continue to operate efficiently without producing hazardous waste, making it a more sustainable long-term solution. The energy grid's reliance on fossil fuels also impacts EV sustainability. In countries where coal power dominates, EVs can have higher well-to-wheel CO2 emissions than a highly efficient internal combustion engine running on biofuels or synthetic fuels. For example, studies have found that in regions with coal-heavy grids, an EV can produce more lifetime CO2 than a hybrid or a highly efficient gasoline engine. Koenigsegg's new engine circumvents this issue by allowing carbon-neutral fuel operation anywhere, making it a more flexible solution for reducing emissions globally. Furthermore, synthetic fuels and biofuels can be integrated into existing fuel infrastructure, meaning that widespread adoption does not require a complete overhaul of refueling stations, unlike the shift to EV charging networks, which demands significant investment and time to develop. This gives Koenigsegg's engine an immediate and practical emissions advantage over EVs in regions where renewable energy infrastructure is still catching up. By combining advanced combustion efficiency, hybrid electric integration, fuel flexibility, and synthetic fuel compatibility, Koenigsegg has created an internal combustion engine that can match or even outperform the life cycle emissions of an EV, depending on how the electricity grid evolves in the coming years. This challenges the assumption that full battery electric vehicles are the only solution for a sustainable automotive future, proving that combustion engines still have the potential to be clean, efficient, and environmentally responsible when paired with the right technologies and fuels. Koenigsegg has once again proven that internal combustion isn't just surviving, it's evolving into something revolutionary. With free-valve technology, extreme efficiency, and multi-fuel capability, this engine is a game-changer, proving that EVs are not the only way forward. While many believe the future is entirely electric, Koenigsegg is challenging that idea by showing that high-performance combustion engines can be just as clean, powerful and sustainable as EVs, if not better. Unlike EVs, which rely on long charging times, battery degradation, and resource-intensive mining, Koenigsegg's engine offers instant refueling, extended range, and significantly lower emissions when using synthetic fuels or biofuels. With free valve technology, combustion becomes more efficient than ever, ensuring maximum power output while minimizing waste and pollution. This engine isn't just about keeping combustion alive, it's about perfecting it. With carbon-neutral synthetic fuels gaining momentum, Koenigsegg's innovation could prove to be a real contender against EVs in terms of sustainability. The question is, are EVs truly the future, or can hyper-efficient multi-fuel combustion engines carve out a path forward? If Koenigsegg's vision becomes a reality, the internal combustion engine may not just survive, it may thrive in a way we never imagined. The battle between EVs and next-generation combustion engines is far from over, and Koenigsegg is leading the charge. Could this be the breakthrough that keeps high-performance combustion cars on the road for generations to come? Koenigsegg has made its move. Now it's your turn. Would you choose this revolutionary new engine over an EV? Let us know in the comments.